Good evening, Professor and ECET350. My name is Adrian Mitchell, and I will be introducing you to our team members and our final project on anti-aliasing and anti-imaging filters. Team D's members consist of myself, Adrian Mitchell, as team leader, majoring in electrical engineering and technology. Alan Aladdin, construction of the circuit on the breadboard, majoring in electrical engineering and technology. Louis Franco, research and development, majoring in electrical engineering and technology. Livio Mosque, construction of multisim circuit, majoring in electrical engineering and technology with a concentration on renewable energy. Now I will turn the presentation over to Livio.
Hello, professor and classmates. My name is Livio Moscu. My major is in electronic technology with concentration on renewable energy. We have a 4 amp op amp design, high order low pass filter that we played with, and we have tested with various resistor and capacitor values, as well as with various frequency values. But multisim did not quite yield the results we would have expected. The highest frequency we used was 15 kHz, but again, results did not quite pan out. The lowest row is actually the formula for the capacitive reactance of the capacitors used. And as you all know, the higher the frequency, the lower the reactance will be. This slide is going to show you the design, the 4 amp op amp design, and the frequency shown here is 1000 hertz. And as you may well notice, the oscilloscopes do not show their ground, but I assure you that those were also properly grounded, and the frequency was again up to 15 kilohertz, and the graph did not change much. I've worked with multisim on other application, and for the most part it proved a fairly reliable application. However, we did not quite get there with our filter design. That being said, I'm going to pass this next slide to our teammate Louis Franco. Thank you.
Hello, Professor Treviso and group. This slide is number 5. I am Ms. Franco. My major is in engineering electronics engineering, I bet. So I'll be talking about this slide number 5 and number 10 as well. So here in slide number 5, we have some questions that were answered while building the circuit. So we have determined the cutoff frequency of the circuit was 1 kHz. The frequency of the signal to be sampled in this case was the same 1 kHz. And the sampling period was 2 milliseconds. The circuit, the sampling frequency was 500 Hz. And the sampling theorem was satisfied, and the reason why is because the sampling frequency was greater and double the max frequency, and also the periodic frequencies are between 0 Hz up to 10 kilohertz, according to sampling theorem.
I'm going to hand the presentation over to Alan.
Hi, my name is Alan and I am in the EET program. So what we have here is our constructed circuit. We have worked with four UA741 operational amplifiers connected to a plus 12 and minus 12 volt power supply. As for the AC power supply, we have an RMS value of 0.707 volts with a frequency of 1 kilohertz. The build of our constructed circuit is very similar to what we have from the multisim, with some minor changes to some of our components. So for one, we have replaced all 11.25 kilo ohm resistors to a 10 kilo ohm. And we have also replaced the transistor from a 2N3685 to a 2N5458, which are both N-channel JFET low noise amplifiers. Unfortunately though, we were not able to generate the pulse voltage, which is supposed to be connected to the gate of the transistor. And this is due to the limited equipment. So this one here is our waveforms from the constructed circuit. The first one is the input of the anti-aliasing low-pass filter, which is connected to our function generator. The second is the waveform for the output of the buffer. And lastly, the third is the waveform for the output of the anti-imaging low-pass filter. Unfortunately, we did not have any equipment to simulate the spectrum analyzers, so the measurements and readings can be found from the multisim. Okay, issues and concerns. So these are cases I have already mentioned. So once again, we have limited equipment. We were not able to generate the pulse voltage, and there was no simulation of a spectrum analyzer on our constructed circuit. So that is it from me, and I will be handing it over to Adrian.
The cost of the project was relatively low. Most of the components that was required for this build were purchased in earlier classes with the startup kit. The components that we needed to buy are listed below, and the total cost was about $6.95. All these components were purchased from Mauser Electronics online. Next, Lewis will give you a conclusion for our project.
So in this case, we were using some principles of signal sampling and reconstruction to build this electronic circuit to sample, hold, and reconstruct the signal wave. The signal were applied. We applied the anti-aliasing and anti-imaging to perform proper simulation of signal sampling and reconstruction. This lab shows us that simple through filter and with the help of Nyquist we can find aliasing and at the same time to correct it by increasing the frequency. So we were able to see aliasing.
So that concludes our presentation and overall our project. Hopefully you have learned something from it, and we all thank you.